All right, hello. My name is Michael Suzuki, and I just wanted to talk about some daily routines and what one I would like to implement. So the one I decided that I wanted to implement is the number talks. And one reason I wanted to implement number talks is because you can incorporate number strings, and number strings have real world application that you can use in various contexts. I really love the idea of incorporating multiple strategies and engaging thinking for the students, modelizing and contextualizing different problems to arrive at a different answer. So I think that there are three main things incorporated with number talks. With number talks, you definitely want to understand the type that you're going to implement. So we decided that's going to be the number string, and you also want to be able to facilitate well. And that's also another aspect I like of the number talks, because when you're facilitating discussion, you're engaging student thinking, and you're effectively encouraging them and inspiring them to think about solving problems in a different way. So facilitating and then also presenting the problem is also another key aspect of number strings. So when you're presenting a problem, you want to make sure that it's very visual and that everyone has the same opportunity to see it. Now, as far as the goals, I think that incorporating number strings is in correlation with 4.0a. So what that says is students should be able to see how 7 times 5 and 5 times 7 is effectively the same thing. That you're taking 5 groups of 7 and you're taking 7 groups of 5 to arrive at 35. And so that's just the process of being able to conceptually think of 7 times 5 in a different way. It's using a different strategy to solve the problem. And I think there's other ways that we can think of 7 times 5, right? Like you can have 7 and then 5 could be represented by 35 over 7. That would be the fractional component of 5. You can use a number line. You can use a chart. You can solve 7 times 5 in multiple ways. I think another aspect of understanding 7 times 5 is scaling. I mean, what are you doing to 7? You are scaling 7 by a factor of 5, right? You're making 7 5 times bigger for 35. On the contrary, you're making 5 7 times bigger. So you're scaling 5 by a factor of 7. So I think being able to conceptually understand that 7 times 5 doesn't have to be thought of as just 7 times 5. You can think of that as 5 times 7. And I think also understanding, that multiplication isn't just making numbers bigger. You can multiply and make numbers smaller. If you multiply 7 by 1/2, you're reducing and scaling that down to 3.5. Same thing for division. When you're dividing 5 by 5, you're making it smaller and that number is going to equal 1. But if you divide 5 by, let's say, 0.1, and then you're effectively multiplying that number by 10. So I think just understanding what is multiplication, what is division. When you're dividing by a number, you're not always making it smaller or always making it bigger. When you're multiplying, you're not always making it bigger or smaller either. It's situational, and we need to help our students understand really what multiplication and division is through visual models, through context, and through real-world examples.